Children, today we are going to learn about disaccharides. What is meant by disaccharides means they are also sugars but having two molecules of monosaccharides. They can yield two molecules of monosaccharides on hydrolysis. So they take the general formula CnH2O n minus 1. This is the general formula for disaccharides. In disaccharides, two monosaccharides can be linked by an oxide linkage that is called glycosidic linkage. How the two monosaccharides are linked? That is by the reaction of anomeric carbon of one monosaccharide with the hydroxyl group of another monosaccharide. Anomeric carbon of one monosaccharide reacts with the hydroxyl group of the other monosaccharides. Already in the previous videos I have shown the open chain structure of glucose, then alpha D, beta D, fructose, alpha D, fructose, beta D, everything I have shown. Glucose takes the pyran form. Pyran means having 6-membered ring, 5 carbon and 1 oxygen. Furan means a 5-membered ring having 1 oxygen. So everything I have taught in the previous videos. Once more I will revise. See, this is the open chain structure for glucose. 6 carbon atoms. First carbon is the aldehyde group. This is the anomeric carbon. And the last one is the primary alcoholic group. Then the remaining 4 carbons. So here the fourth carbon, the hydrogen shifted to the first carbon, aldehyde carbon, that is the anomeric carbon. So the structure changes to alpha D glucose and beta D glucose. Alpha D means OH is present on the right side, beta means OH present on the left side. Everything this I have taught in the previous videos. Similarly, fructose, if you are taking, means having a keto group in the second carbon. So from the fifth carbon, the hydrogen transfers from here to here. So this structure changed into a 5-membered ring. So this is the alpha D fructose having OH in the right side and beta D fructose having OH in the left side. So these are and all I have taught in the previous videos. Now there are 3 types of disaccharides. One is the sucrose, the second one is the lactose, the third one is the maltose. These 3 are disaccharides: sucrose, lactose, maltose. Both 3 having two monosaccharides. That only we are going to see now. Suppose if you are taking sucrose, means it is the combination of 2 monosaccharides, that is sucrose. See, sucrose in the presence of an enzyme invertase, it divides into glucose plus fructose. These 2 are monosaccharides. So sucrose having the meter rotation plus 66.6 degree, glucose plus 52.5 degree, this glucose. Now the fructose having minus 92.4 degree. This is the meter rotation values of these 3. So here this is the positive value, this is the positive value, this is the negative value. So when you are simplifying the net, we are getting a negative value here. So the dextro, positive means dextro, negative means levo. So dextro becomes into levo. That is called invert sugar. Invert sugar or invertase. Here in glucose, after the aldehyde group changes by shifting the carbon, There is no aldehyde group in glucose now, alpha D glucose and beta D glucose. No free aldehyde group. So these are also, so sucrose, since no free aldehyde group here, it is also called as non-reducing sugar. Sucrose, commonly known as table sugar. It is obtained mainly from the juice of sugarcane, sugar beets, insects such as honey bees. Sucrose, commonly called table sugar, it is obtained from the juice of sugarcane or sugar beets. Here this sucrose converted to glucose and fructose in the presence of an enzyme invertase. This invertase can be obtained from the honey bees. Most of the honey bees having the enzyme this invertase. So sucrose is a mixture of glucose and fructose. Now we are going to see the structure. Here I already told here the two monosaccharides linked by oxide linkage called glycosidic linkage. That only I will show you now how it is linked. This is alpha D glucose. Sucrose is the combination of two monosaccharides. One is the alpha D glucose, the other one is the beta D fructose. Alpha D glucose, beta D fructose. Glucose always take the shape of a pyranose, 5-membered ring. So, 6-membered ring, 5 carbon atom, 1 oxygen atom. Fructose always take the shape of a furan. So I'll show how to draw this alpha D glucose. Already I have taught in the previous videos how it is drawn. 5 carbon, 1 oxygen. So here HOH. So I'll draw in pencil HOH. The next carbon also HOH. HOH. Third carbon OHH. Fourth carbon HOH. Fifth carbon HCH2OH. So HCH2OH. CH2OH. This is the alpha D glucopyranose. Now next, beta D fructose. I'll show this is the 5-membered ring. Five-membered ring. So here this one is first carbon, second, third, 4, 5, 6. Here also this is the first carbon. So CH2OH below 1 OH here, OH, next H, OH, next also H, OH, next H, CH2, OH, 1 O, that only here. Now here this first carbon, second, third, 4, 5. Already I told two monosaccharides are linked by the oxide bridge that is called glycosidic linkage. Now you see HOH, CH2OH below 1 OH is kept. Now here okay, here one water molecule is removed. HOH and water molecule is removed. So now I will rub. So now only one O is there, a bond is formed. This is the first carbon. Children, this is the first carbon, and this is the second carbon. Second carbon. This is the first carbon, this is second carbon. So first carbon, second carbon linked by a oxygen. That is called glycosidic linkage. First you should be thorough with this structure, then only we can draw like this and we can show the removal, how it is removed. This is called alpha 1, 2 glycosidic bond. C carbon 1 of alpha D glucose joined to C2 of beta D fructose. That bond is formed called as alpha 1, 2 glycosidic bond. So here the dextro form changes to a levo form because the net charge is negative. This is called as invert sugar or invertase. That you should not forget, invertase. And here no free aldehyde group, so it is also called as non-reducing sugar. Children, I think you are all clear with this. Sucrose, you are all clear with this. It is clearly given in your book page number 247.